All right, let's talk about three of the biggest buzzwords flying around right now: artificial intelligence, machine learning, and deep learning. You hear them all the time, right? And a lot of people use them like they mean the same thing. But they don't, not even close. So today, we're going to untangle this mess and figure out what each one really is and why it's so important to know the difference. I mean, seriously, they're everywhere. Headlines, meetings, your news feed. But what's the deal? Are they all the same? Is a chatbot that answers your questions basically the same tech as a car that drives itself? Or is your Netflix recommendation just a simpler version of an AI that can spot cancer on an X-ray? The answer, in short, is nope, they're not. And the best way to get your head around it is to stop thinking of them as a list of buzzwords and start seeing them as a family with a really clear pecking order. Actually, you know what? The perfect way to picture this relationship is to think of those Russian nesting dolls. You know the ones, right? You've got the big doll on the outside, and you open it up, and there's a smaller one inside, and an even smaller one inside that. Each one fits perfectly inside the other. It's a perfect hierarchy. So, let's start by opening up that biggest, outermost doll. So, that largest doll, the big one that holds everything else, that is artificial intelligence, AI. This is the granddaddy of them all, the big umbrella idea that started this whole journey, the simple, massive goal of making machines smart. At its most basic level, AI is really just any technique that lets a computer mimic human intelligence. Think about what that means. Reasoning, learning, solving problems, all those things we do inside our own heads. It's the foundational dream, right? The idea that a machine can actually think. And here's the thing. You're already using it, constantly, probably without even realizing it. When you ask Alexa or Siri for the weather, boom, that's AI. When Netflix just knows somehow what movie you're in the mood for next, that's AI. And when Google Maps cleverly reroutes you around a traffic jam, yep, you guessed it, that's AI doing its thing. Okay, but here's a really, really important distinction to make. Every single piece of AI we have today is what experts call narrow AI. That means it's incredibly good at one specific thing, like playing Go or recognizing your face or optimizing a delivery route. This is a world away from the science fiction stuff, a machine that can think and create and learn about anything, just like a human. That's called artificial general intelligence, or AGI. And trust me, we are a long, long way from that. So, if AI is the goal, how do we get there? How do we actually make a machine intelligent? Well, that brings us to our next nesting doll. We're opening up AI, and inside we find machine learning. And this isn't just another word for AI. It's a very specific and very powerful way to build AI. This is where the whole approach kind of flips on its head. See, with old school programming, a human had to write out every single rule step by step. If this, then that. But with machine learning, we do the opposite. We just throw a ton of data at the system, and we let it figure out the patterns. It literally learns from experience, kind of like we do, instead of just following a strict set of instructions. And this quote here just nails it. The algorithm can make predictions without being explicitly coded to produce any of them. That's the magic trick right there. The machine develops a kind of autonomy. It can look at a situation it has never, ever seen before and make a smart guess based on everything it's learned. It's not just following orders anymore. And you see this everywhere in the business world. Spotify learning your taste in music to build that Discover Weekly playlist that's creepily good, that's machine learning. Companies using it to predict which customers are about to cancel their service. Sales forecasting, analyzing warranty claims, and of course, Amazon recommending products. It all boils down to one thing: finding patterns in data to make predictions. Okay, time to open up doll number 2. Inside machine learning, we find our third and final doll, the very core of our set: deep learning. Now, this is a type of machine learning, but it's a super specialized and incredibly powerful version that's behind almost all of the mind-blowing stuff you've been hearing about lately. The secret sauce here is something called an artificial neural network. Just try to picture a system with layers upon layers of tiny little calculators, or neurons, all connected and working together. The whole structure is kind of inspired by how our own brains are wired up. And it's those multiple deep layers that give deep learning its name. And this is what makes deep learning a total game changer. Your standard machine learning is awesome with neat, tidy, structured data, like spreadsheets and tables. But deep learning, It thrives on the messy, complicated, unstructured stuff that makes up most of our world. We're talking about images, video files, raw audio, and just plain old text. This ability unlocks things that were basically science fiction a decade ago. The vision system in a self-driving car that can see and understand a busy street, that's all deep learning. The facial recognition that unlocks your phone, yep, deep learning. Those super advanced chatbots that can actually hold a conversation, or the apps that translate languages in real time, you guessed it, it's all powered by deep neural networks. Okay, so we've got machine learning, and we've got its super-powered kid, deep learning. They're related, but different. So how do you know which one to use? Well, it's all about picking the right tool for the right job. Let's put them side by side. This really breaks down the practical differences. So traditional ML, it's happy with smaller, structured data sets and can run on a normal computer. But here's the key part. It usually needs a human expert to pre-process the data and tell the machine which features are important to look at. Deep learning, on the other hand, is hungry. It needs huge data sets and powerful specialized hardware like GPUs for gaming. But its massive advantage, it figures out what's important all by itself, straight from the raw data. So you can see, it's a trade-off. For a lot of everyday business problems, like forecasting next quarter sales from a spreadsheet, traditional ML is way cheaper, faster, and honestly, it's more than good enough. But when you get to the really complex stuff, tasks that involve perception, like analyzing medical scans or understanding spoken commands, that's where the raw power and accuracy of deep learning becomes absolutely non-negotiable. Okay, so we've gone through all these definitions, but why does any of this actually matter? I mean, who cares what it's called? Well, understanding these differences is way more than just a geeky trivia question. For any business trying to use this tech, getting it wrong can have some pretty serious consequences. And this quote just hits the nail on the head. You can't confuse a chatbot for a magic wand. In other words, if you don't understand the capabilities and limitations of the tool you're using, if you expect a simple model to do something that requires a deep neural network, you are just setting yourself up for disappointment. It's a huge waste of time and money, and it can kill a company's innovation efforts before they even start. So if you're in a position to make this choice, how do you get it right? Well, you can boil it down to 4 key questions. First, and most important, start with your data. Is it nice and organized in a spreadsheet, or is it a mess of images and text? Second, what's the problem you're trying to solve? Is it a prediction, or is it perception? Third, be real about your budget. Traditional ML is way more accessible. And fourth, how accurate do you need to be? If it's a life or death decision, like a medical diagnosis, you're probably going to want to invest in deep learning. And that's really what this all comes down to, isn't it? The goal here isn't just to use the fanciest, most advanced technology for the sake of it. The real goal is to deliver actual, tangible business value. You always have to start with the problem and then pick the right tool to solve it. So to wrap this all up, let's go back to our nesting dolls one last time. AI is that big outer doll, the whole idea of smart machines. Inside that, you have machine learning, a way to create AI by letting it learn from data. And at the very core, you have deep learning, a special kind of ML that uses brain-like networks for really complex problems. And remember, choosing the right one always comes down to your data, your budget, and the specific problem you're trying to solve. We've gotten really good at this narrow AI, creating systems that are superhuman at one specific thing. But that leaves us with a pretty big and kind of mind-bending final question. What happens when we finally crack the code for artificial general intelligence, an AI that can reason, learn, and create across any field, just like a person can? Now, that's a thought for another day. Thanks for joining me.